8b, perimeter. Okay, so we're going to start working with some different shapes, and let's talk about three basic shapes that we're going to deal with, which are triangle, rectangle, and square. So you should be familiar with these shapes. A triangle is a closed two-dimensional figure consisting of three sides. Each of those sides is a line segment, meaning it's a section of a straight line, and it has three angles. And those angles can be any angle that makes it work. We don't really need to know this right now, but the sum of the interior angles, the sum of these angles is 180 degrees. But that's not critical for us to know. We just have to realize that there are three angles and three sides, and that makes a triangle. A rectangle is a closed two-dimensional figure, and I should explain that closed means that you have to go through one of the sides to get into it, as opposed to having something like this where we can just get right into it. Okay, so it's a closed two-dimensional figure. Two-dimensional means it's flat, right? With four sides and four angles. The sides consist of line segments, so a straight piece of a line. And the angles, all four of them are right angles or 90-degree angles. Opposite sides are the same length, but adjacent sides can be different from one another. But the opposite sides are the same. So if this is 8 meters, that's 8 meters. If that's 2 inches, that's 2 inches. So that's a rectangle. And then we have a square. A square is a closed two-dimensional figure consisting of four sides. Each of the four sides has an equal length. And all of the four angles of it are right angles. A square is actually a special case of a rectangle because not only are opposite sides the same length, but all sides are the same length. So a square is just a rectangle where all of the sides are the same length. Well, now that we have these, we can work with perimeter. Perimeter is just the distance around the shape, or the sum of all the exterior sides. So the perimeter of a triangle would be this side plus this side plus this side. So it's just the sum of the three sides. Perimeter of a rectangle would be the sum of all four of those sides. Of a square, the sum of all four of those sides. And we're gonna give some basic equations for this. Well, with this triangle, those three sides of a triangle can be any length. So we're going to say S sub 1, S sub 2, S sub 3. S for side, and the number 1, 2, or 3 is what we call a subscript. And what that does is it just says, this is a variable, this is a variable, this is a variable. They're all called S, but they're three different variables, so we put the little subscript there. It does not mean any numerical operation. So we're not multiplying S by 1 and S by 2 or S by 3. We're not squaring them. We're not doing any operation on them. It's the same as if I called this A, B, and C, but we're just going to think of this like side 1, side 2, side 3. So the first side, the second side, the third side. So the perimeter, which we use a capital P for perimeter, for a triangle is just the sum of those sides. So S sub 1 plus S sub 2 plus S sub 3. For a rectangle has a length, that's a lowercase l, and a width, lowercase w. So The opposite sides are the same length, so that's another L and that's another W. So our perimeter is equal to L plus W plus L plus W, or that's 2 L's plus 2 W's. So that's 2 times the length plus 2 times the width. So the the perimeter of a rectangle. And then when we're dealing with a square, all the sides have the same length, so we just use S for that. So the perimeter of a square is just 4 times S, because we have 4 sides, all of length S. And that's how we find the perimeter of a triangle, a rectangle, or a square. So let's try some examples. We'll get these out of the way. So I have a triangle with sides of length 5 centimeters, 7 centimeters, and 6 centimeters. Now realize that my figures are not necessarily drawn to scale. So you see that these sides all look like the same length, but I'm calling them different things. Realize that's just a reality of drawing figures quickly. So if I want to find the perimeter, then I'm going to add up those sides. So I have 5 centimeters plus 6 centimeters plus 7 centimeters. Well, if I have 5 centimeters plus 6 centimeters, that's 11 centimeters. Plus 7 more centimeters gives me 18 centimeters. Centimeters is the unit. So that's our unit of measurement. We're measuring in centimeters as opposed to measuring in inches or feet or meters or miles. Whenever we're dealing with perimeter is a length. So it's going to have a unit attached to it. It's just going to be a basic unit. So centimeters in this case. If this had been 5 inches, 7 inches, and 6 inches, then we have 18 inches. So that's finding the perimeter of a triangle. Well, let's try a rectangle. Let's say I have a rectangle that is 13 inches by 8 inches. Now, given that information, we know that the length of this side is 13 inches, and that the length of this side is 8 inches. We know that because for a rectangle, opposite sides have the same length. If we want to find the perimeter of this rectangle, we're going to take 2 times 13 inches, plus 2 times 8 inches. 2 times 13 is 26 inches. 2 times 8 is 16 inches. 26 inches plus 16 inches, 42 inches. So to find the perimeter of a rectangle. Well, what about a perimeter of a square? I think we can squeeze that in right here, assume that my angles are actually right angles and these sides are all the same length. Let's say that the length of a side is 5 meters. Well, if that side's 5 meters, then this one's 5 meters, and this one's 5 meters, and this one's 5 meters. Perimeter is equal to 4 times the length of a side, 5 meters. 4 times 5 meters is 20 meters. So I'll put that right down here just to be consistent. Oops. So 20 meters. So find the perimeter of a triangle, a rectangle, and a square. Now, we don't always have nice shapes like this where we have a triangle, a rectangle, or a square. So how do we find the perimeter of other shapes? Because with these we had formulas. Well, the reality of it is that with a with perimeter, you don't really need a formula. The formula is add up all the sides. So if I have a shape like this, and I have the measurements, so let's say that this is 1 inch, and this is 7 inches, 8 inches, 5 inches, let's make this one 6 inches, 10 inches, 12 inches, and 15 inches. So now I have a shape, and I have all the sides. The perimeter is just the sum of all those sides. So the perimeter, and I'm going to save myself a little bit of work here. In the other examples, I put the units in all the way through it, right? Well, I'm not going to write down 7 inches plus 8 inches plus 5 inches plus 15 inches. They're all in the same unit. So when I get done, my perimeter is going to be the sum inches. So I'm going to save myself a little effort and just go 7 plus 8 plus 5 plus 15 plus 10 plus 6 plus 12 plus 1. Right? 7, 8, 5, 15, 10, 6, 12, 1 puts me back to the beginning again. 7 plus 8 is 15, plus 5 is 20, plus 15, 35, plus 10, 45, plus 6, 51, plus 12, 63, plus 1, 64. And then the unit was inches, so the perimeter is 64 inches. It doesn't matter what the shape is. We just have to add up all the sides. I'm going to take you to something a little more complicated. One where we have to do a little bit of figuring to determine what some of the sides are. It's not too much more complicated, but let's say I have 8 meters, 7 meters, 3 meters, and 2 meters. So now I have this L shape, and I want to find the perimeter. Okay, I'm going to switch to a different color just so it's obvious what we were given and where we're going with it. So I have these measurements, but if I want to find the perimeter, I also need the length of those two sides. Now, assuming that these are all right angles, then we can find the length of these missing sides, because if I extend this out, the distance from here to here plus this distance is equal to this length here. So if the full length is 8 meters, and this part of it is 3 meters, then this part of it must be 8 minus 3, or 5 meters. And I can do the same thing with this side here. If the whole thing is 7 meters, and this part of it is 2 meters, then this one must be 7 minus 2, or 5 meters. Now that I have that, I have measurements for all the sides, I can find the perimeter. So I have 2 plus 8 plus 7 plus 3 plus 5 plus 5. 2 plus 8 is 10, plus 7 is 17, plus 3 is 20, plus 5 is 25, plus 5 is 30. So we have 30, and the unit was meters. So 30 meters. So So we started out with what was in blue, and then we found the rest saying, well, we know this distance. Well, that's got to be this distance. If I take that away, that's what's left. So 7 minus 2 gave me 5. If I have this full distance here, and this is doing this part of it, the rest of it must be 8 minus 3, or 5. Now I'm going to make this just a little more complicated. We've been doing well thus far. Okay, so I've got some, I don't know, it kind of looks, if I did like a swirly thing here, kind of reminds me of turbo. A snail, right? Okay, so I have this. That's 2 meters, 13 meters. Make this 8 meters. 12 meters, 9 meters, and make this 5 meters. Okay, so similar to our last one, where we had some missing sides, so don't just add it up, we're still missing these 2 sides, but how do we find those extra sides? Well, we're missing some stuff here. It's like, what I did last time was I said, well, this full length is this, so if I know this length, which I don't, then I could find that, but I don't know that length. This other way, not too bad, because I do have the full length. I know this length, and I know that length, so this has just got to be what's missing. So let's start there. 12 minus 8 is 4. 4 minus 2 is 2, so this one's 2 meters. So that was relatively easy to find. It's this other one that gets a little more difficult. How do I find that? I don't know this. Well, I can know this, because using what we did last time, here's 9, here's 5, that means this distance here must be the other 4 meters. Right? I've got 9 meters, take away the 5, I'm left with 4 meters. So that means that distance there must be 4 meters. And if that's 4 meters, and the total of this is 13 meters, 13 meters minus 4 meters gives me 9 meters. So now I have the missing pieces that I can do this. Be careful. The final mistake that people tend to make with this is they want to count the 4 meters there in their calculation. Remember, we're just looking for the sides. So we're going to add up all these sides. Those 4s that we got here were to help us find these missing ones. So the perimeter, let me switch back to blue, is equal to the sum of all of these. So I have 2 plus 13 plus 12 plus 9 plus 8 plus 5 plus 2 plus 9. 2 plus 13 is 15, plus 12 is 27, plus 9 is 36, plus 8 is 44, plus 5 is 49, plus 2 is 51, plus 9 is 60, a total of 60, and the units were meters. So the perimeter is 60 meters. So we had to find these missing pieces. This one was easy because we just knew the total was 12, and we subtracted the 8 and the 2, which took us down to 2 meters. This one was a little more difficult. We knew this full distance, but we didn't know either this or this, so we had to come over here, and we knew 9, this was 9, so subtract the 5 gave us the rest, so that gave us 4 meters, therefore this minus the 4 meters gave us our other 9 meters. Now the last thing we want to do with this is we want to look at it algebraically. I know that word hurts your ears. Algebraically, that means we're going to put some variables in and create a formula from that. A rectangle has a length that is triple its width. Write an equation for the perimeter of the rectangle in terms of one variable. Now remember, a variable is just a letter that represents it. So I want to write an equation for the perimeter. Now remember that the perimeter of a rectangle is equal to 2 times the length plus 2 times the width. Now we want to do this in terms of one variable. Well, that's 2 variables. Well, what can we get from here? A rectangle has a length that is triple its width. What does triple mean? It means 3 times. So the length is 3 times the width. So L is equal to 3 times W, right? L is the length is triple the width. Now that we have that, if I want to write it in terms of one variable, all I have to do is substitute 3W anywhere I see L. So I can say the perimeter is equal to 2 times 3W plus 2W. Now I don't want to leave it like that. I see this 2, I'm going to multiply it by the 3W, so it is equal to 6W. 2 times 3 is 6. Just going to make my W look a little more like a W. Plus 2W. And if you remember combining like terms, we have 6 W's. If we add 2 more W's, we end up with the perimeter is equal to 8 W's. Or the perimeter is equal to 8 times the width. So let's switch to red and say, well, what if I know that the width is equal to 5 inches? What is going to be the perimeter of this rectangle? P is equal to 8 times 5, or 40 inches. So we were able to create a formula from words, do it in terms of one variable, and then we were able to utilize that, plugging in a value for that variable to find out the perimeter, given that the width is 5 inches. We could do the same thing and say, what if the width is 1 inch? 8 times 1 is 8. Then the perimeter is 8 inches. And that's perimeter.